Serverless computing. It's been a total game changer, right? Developers can now build and launch apps without even thinking about a physical server. It's fast, it's incredibly scalable, and it lets teams focus on what really matters, building amazing products. But, with this new power comes a whole new set of risks. We're talking subtle, hidden dangers that the old ways of thinking about security just weren't built to handle. So, what are these hidden risks? Well, let's dive in and break it down. First up, let's just make sure we're all on the same page. When we say serverless or function as a service, what are we actually talking about? Put simply, it's a setup where the cloud provider like Amazon, Google, or Microsoft manages all the server infrastructure for you. All you have to do is write your code in these small, self-contained pieces called functions, and the provider just runs them whenever they're needed. No setting up servers, no maintenance, just pure code.
And the appeal here is massive. You get to focus only on your app's features. You can completely forget about the operating system or what version of a runtime you're on. Say goodbye to those late-night emergency security patches for your servers. And maybe best of all, your app scales automatically. It can go from 1 user to 1 million without you having to lift a finger. It's basically a developer's dream come true.
Okay, so if the cloud provider is handling all the servers and doing all the patching, does that mean security is just a solved problem? Can we all just pack up and go home? Well, not so fast. The reality is that security hasn't gone away, it's just changed. The responsibilities have shifted. This is the absolute key question, isn't it? And the answer is a huge, resounding no. While the provider does take on a massive amount of the security work, a really critical set of responsibilities now falls directly onto your shoulders as the developer.
And this is where the shared responsibility model comes in. Look at this diagram. The provider takes care of securing the cloud, all that stuff in orange. We're talking the physical data centers, the networking, the operating systems, but you are responsible for securing what's in the cloud, everything you see there in blue. Think of it like this. The provider built you a super secure apartment building with guards and cameras, but you still have to remember to lock the front door to your own apartment.
This table really makes it crystal clear. They handle the physical hardware, you handle your application's logic and code. They manage the core network, you have to manage who and what gets to access your functions and your data. They patch the OS, you have to protect your data, both when it's sitting still and when it's moving around. The big takeaway here is that your job didn't disappear, it just got a completely new focus.
So where do these new responsibilities actually pop up? Well, let's start with the most obvious place, the code that you write and the data that it touches. This is your new attack surface.
The number one top risk, according to the Cloud Security Alliance, is something called function event data injection. Now, we've all probably heard of things like SQL injection from a web form, but in the serverless world, it's so much bigger than that. Your functions aren't just triggered by someone clicking a button on a website. They can be triggered by a file getting uploaded to a storage bucket, a message from an IoT sensor, you name it. Each one of those event sources is a new door that an attacker could try to break through.
Let's make this super concrete. Imagine you've built a serverless app that processes job applications. An attacker emails a resume, but instead of naming it resume.pdf, they give it a malicious file name that's actually a hidden command. Now, if your application blindly trusts that file name and passes it into a system command, poof, that hidden command runs. And just like that, the attacker could steal your secret API keys, your database credentials, all kinds of sensitive stuff. And here's the real kicker. The security tools we're used to, our traditional scanners, they often completely miss these kinds of problems. They were designed to analyze big, monolithic applications with a single front door, the web API. They just aren't well equipped to analyze this new world of distributed functions being triggered by dozens of different events.
Okay, so securing your code, that's one piece of the puzzle. But an even more common way that cloud environments get breached is through simple misconfigurations. We're talking about one wrong setting, one tiny mistake in a config file that can open up a massive security hole.
And that brings us to a huge one, overprivileged functions. There's a core idea in security called the principle of least privilege. It just means something, a user, a function, whatever, should only have the absolute minimum permissions it needs to do its job, and nothing more. Anything extra is a risk. An overprivileged function is one that's been given the keys to the entire kingdom when it only needed the key to one room.
And as you can see here, managing permissions in serverless is a whole new ballgame. In a traditional app, you might have a handful of roles for your users. In a serverless app, you might have hundreds of different functions, and ideally, every single one of them gets its own unique, tightly controlled role.
The payoff is that you can dramatically shrink the blast radius. If one function gets compromised, the damage is contained. But that's a big if. It only works if the permissions were locked down correctly in the first place.
And wow, this slide just says it all. Look at the code on the left. See that little asterisk, that star, after DynamoDB? That one little character is a wildcard. It gives this function permission to do literally anything to the database. Read data, write data, even delete the entire table. A vulnerability there would be catastrophic. Now look at the right. The permission is locked down to one single action. Put item. That's it. That is the principle of least privilege in action.
All right, so we've talked about securing our code and locking down our permissions. But there's one more category of risk, and honestly, it's maybe the most unique to the serverless world. It's about exploiting the very architecture of the application itself.
I want you to think of a serverless application as a chain of events, like a series of dominoes. Function A does its thing, which triggers function B, which then triggers function C. But what if an attacker could just skip the line? What if they could trigger function C directly, completely bypassing the security checks you put in functions A and B? That, right there, is business logic manipulation. This diagram is a perfect example of this in the wild. The proper flow for a user is to go through that API gateway on the left. It checks who they are, then a function checks that their file isn't too big. But the attacker is clever. They notice the storage bucket itself is poorly configured. So they just upload a massive file directly to the bucket, completely sidestepping the authentication and validation steps and triggering that final processing function. So what's the damage? Well, it can be really bad. By uploading huge files over and over, the attacker can jam up the whole system, causing a denial of service for your real users. Or even worse, they can trigger something called financial resource exhaustion. This is where your app doesn't crash. It just runs and runs and runs, racking up costs until you get a cloud bill for thousands or even tens of thousands of dollars. It's a nightmare scenario. So if you take one thing away from this whole explainer, let it be this. Securing serverless applications requires a fundamental mental shift. We're not focused on hardening one server inside a firewall anymore. We have to think about securing the entire distributed flow of data and execution as it jumps between dozens of different cloud services. It's about securing the flow.
So what does this new mindset look like in practice? Well, it means you're applying that principle of least privilege to every single function. It means you're treating every single event source, every storage bucket, every message queue as a potential front door that needs a lock. It's about watching the interactions between your functions, not just the functions themselves, and building your application so it can't be tricked into running out of order.
At the end of the day, as the Cloud Security Alliance puts it, the goal here isn't to scare anyone away from serverless. It's the opposite. It's about empowering all of us to build these amazing, next-generation applications that aren't just scalable and efficient, but are also robust, reliable, and fundamentally secure.
So I'll leave you with a question to think about for your own projects. In this new serverless world, where's your biggest risk really hiding? Is it in a single line of buggy code inside one of your functions? Or is it an insecure, forgotten connection between two cloud services that lets an attacker bypass your entire security model? The answer might just surprise you.